today is Patrick Delancy. Patrick, how are you?
Hi, I'm doing great.
Hey, where are you from?
I'm from Kansas City, Kansas.
Kansas City, Kansas, great city.
Yeah, I like it there.
And you're in Ohio talking about memory management and .NET, right?
I am.
You know, the reason I actually develop in .NET is so I don't have to think about memory management. You're telling me now that I do have to think about memory management. I thought that was all taken care of.
Well, in general, it is taken care of. I don't know that you necessarily have to think about memory management, but one of the things as we try to become better developers, sharpening our sword and becoming smarter and using the framework better.
Right.
There's a lot of stuff that the garbage collector does, and generally does its job pretty well.
Mm-hmm.
But because it's doing a lot of things for us, there's sort of a black box.
Right.
And if we don't understand how that black box is doing its work, in terms of memory management, it can actually be bad for performance for application.
Okay. I have seen non-performant applications before. I've seen applications that waste a lot of memory.
Right.
And sometimes that does confound me, so I confess that I've fallen into this trap a couple of times. I should be thinking about it. If I understood that block box a little better, maybe my application would be better or faster or more scalable or something.
Yeah. In general, garbage collector takes care of cleaning up memory. If an object isn't referenced anymore, then that memory is now eligible to be used by other parts of your application.
Okay.
But there's some other reasons why you may not realize that some of your variables may get rooted in the garbage collector.
Rooted?
When a variable is rooted, that means that it has a connection to the top of your application.
Okay.
So
it's never going to go out of scope until your application ends.
Right, and that's how the garbage collector knows that it's still alive.
Okay.
So the garbage collector will start at the top, of any static objects. It'll be a starting point for the garbage collector to trace references.
Okay.
Or GC handles, which is a special construct that you can use, especially for like interop with native memory. You can pass a managed object to native code by using a GC handle or pinning it in memory.
Okay.
So then the garbage collector walks those references all the way down until the end to all the leaves of your object references.
Okay.
And everything else is considered dead.
All right. This frees us from having to do pointer counters that a lot of people have to do. Do I have how many things are referencing me? And once that gets to zero, then we know, okay, now we're okay.
Yeah.
Basically, the framework does that for us.
Yeah. Well, it's sort of a different model.
Right.
Like in ObjectiveC, it uses reference counting.
Okay.
Like you're describing. In the .NET framework, it uses something called mark and sweep, which is just what I described. It starts at the top, it finds out what's still referenced,
Okay.
and then it sweeps through and cleans up everything else.
Okay. All right. And so well, let's talk about when I should be thinking about when is it an issue for me. Most of the time, I will say this, that it's a good thing that I don't have to think about memory management most of the time. It frees me up. The time that I would be spent doing reference counting or managing pointers or all the hard things in C++, I can now spend the same time and energy writing business logic.
Right.
That's great. But so where should I be focusing?
One of the things is when garbage collector is running, it's doing processing.
Okay.
And so when the garbage collector is running, that takes away processing resources from the rest of your application.
Okay.
So you can actually see sometimes one of the default modes of the garbage collector is the thread that triggered the garbage collection. It's trying to allocate memory, there's not room for it. That thread will actually do the garbage collection. And then the other threads are suspended while that's happening.
So garbage collecting is expensive.
So, and obviously that can be visible in the UI then. Right. Generally, garbage collection for generation 0 will take 15 milliseconds or something. Usually very short. But if you have a lot of objects in memory, a deep reference tree, then it can take longer. So one of the things you can control about the garbage collector is something they call a latency mode. So if you know that you're about to do something that is very important, doesn't slow down in the UI, or you're streaming something to an external system, it's very important that it's real time, then you can change the latency mode of the garbage collector so that you can say that for this period of time, for this block of code,
Okay.
I want it to be as fast a throughput as possible for the processing. And that'll tell the garbage collector to do things like don't allow garbage collection on generation 2 objects or large objects. It just won't do it at all. It'll
Okay.
block it.
So we'll suppress garbage collection for certain unnecessary things or lower priority
Right.
things.
And then the sacrifice is, since it's not getting collected, it's just adding more and more memory.
Okay, so you sacrifice extra memory for more throughput.
Correct.
All right. How do you do that? Is that through code you do that, or is it through
It's actually
configuration?
a static on the gc.latency mode. It's a static.
So you just call it the static method, or is that?
Yeah,
is that static
you
property?
set the static to it's an enumerable
Okay.
for latency mode.
All right. Okay.
Another thing that some people aren't aware of, disposable objects.
Okay.
We've almost all used them, but the disposable method does not get called by the CLR automatically.
Okay. Let's back up a step here.
Oh,
The
sure.
disposable method is what? What's it designed for, and when is it called?
The disposable method, the disposable pattern we hear mostly referred to, it's a mechanism for your objects to clean up its own managed resources.
Okay.
So if you have an object that maybe it uses a lot of memory,
All right.
like when it's in use, it takes up a lot of space in memory, and the dispose method it's a mechanism that you can provide that'll allow when somebody using your object is done, it can say, I'm now done with this object.
Okay.
Then it gives you an opportunity to clean up all those resources.
Okay. Well, so let me stop you for a second there, because I thought that when you're dealing with managed objects, that when you stop using them and there's no more calls to them and no more reference to them, that the garbage collector would take care of just exactly what you described. Is that not true?
It is true in terms of the memory.
Okay.
So whatever local variables are created by that object, when it goes out of scope, garbage collector runs and it doesn't find any references to it, then it'll be eligible to get collected.
Okay.
But there's times where you need to do some processing to clean up your object.
Give me an example.
Well, I think of it like a file handle.
Okay.
The general pattern for a file handle is you would open the file and then read something from it, write to it, whatever, and then close the file when you're done.
Okay.
If you have an object that maybe opens a file in the constructor, and then that file is now open, you have a handle to that file, and internally that file, that system file object has reference to a native file handle.
Oh, okay.
So then the most performant way to use that is to, as soon as you're done with it, your own object has finished. You're done using your object, so it's open in the constructor. You need some way to close that object.
Okay.
And dispose is one of the simplest ways to do that, because there's some extra sugar built into the language.
Okay, so these file objects, or the file info object or whatever, things in the system.io namespace,
Right.
those they have a dispose method that I can just call, and inside of that dispose method, it'll take care of cleaning up its unmanaged resources.
It'll.
And this is important. Sounds like an important distinction. I care about that because even though these file objects are managed resources, they have references to unmanaged resources. Is it the fact that there's some unmanaged objects in there somewhere?
Correct.
That makes this an issue?
Yes.
Okay.
And again, it's really for performance.
Yep.
This idea of a finalizer, that will run, the framework will actually call that.
Okay.
But that'll happen later.
What's the reason to dispose and finalize it?
Dispose, you have to call.
Okay.
Finalize will get called by the CLR, but it doesn't happen at the same time.
Okay.
So when you call dispose, you tell it when you're done with that object, and it'll clean up everything right then, and then you don't have to worry about it happening later or interrupting something.
Okay.
So finalization, when a garbage collection runs, if an object has a finalizer, it gets put onto a queue. So that object still survives the first garbage collection, even if it's no longer referenced.
Okay.
So that object still survives, and then that finalizer has a whole separate thread that's running while your application is running. And it's going through the finalizer queue, running those finalizers. And it does that at the highest thread priority.
Okay.
So it's really for performance that when you're done with an object, you call dispose, then that handles all the cleanup. If it's written correctly, it handles all of the cleanup. And then you can tell it, this object, even though it has a finalizer, doesn't need to be finalized. So then
How do you tell them that?
there's a method on the static GC object that's suppress finalize.
Okay. What's the penalty if you don't tell it that? If you don't suppress finalize?
The penalty is it goes onto the queue. That object lives longer than one garbage collection.
Oh, okay.
And then that finalization happens at the highest thread priority while your other threads are running.
Okay. All right. I want to tell you. I want to share a story about a project I was on one time where we were looking at code that was performing very slowly, and one of the things that I saw in here is that the people that came to review this code before me, they had scattered code in there to just run the garbage collector. Periodically, they were just running garbage collection. And I forgot the command to do that, but
Yeah.
but they were explicitly calling it. Is that? I don't think it was doing any good. But was that actively harming the application? Do you think harming performance?
Yeah, it actually could be reducing the performance of the system of the application. The garbage collector runs at specific times. If the host system says it's low on memory, then it could notify your application that it needs to run garbage collection. Or as you're allocating objects, there's this threshold that's sort of a moving target based on your application. It kind of optimizes it.
Okay.
There's this threshold. If your allocated memory gets over that threshold, that'll trigger a garbage collection.
Okay. And that's based on the total memory that you have on the system, right?
Yeah, it's actually based on by generation,
Okay.
by object generation. And then, you, like I said, you can call it manually. But there's specific situations that it's really ideal. So the whole idea of garbage collection is you want to simulate that the system has unlimited memory.
Okay.
And the garbage collector facilitates that. So you keep allocating memory, and then you don't have to go back and free all of those objects.
All right.
So it's trying to simulate an infinite amount of memory.
Okay. And this is what I was talking about earlier, that it frees me about from thinking about memory.
Right.
I just don't think of memory as a constrained resource.
Yeah.
Generally speaking,
Right.
unless I'm calling COM objects through interop, and then a red flag goes off in my head. But I don't think I'm thinking about it enough. I'm not thinking about it in terms of managed objects that call COM objects, for example.
Yeah. One of the most important things I think to learn about how garbage collection works is understanding how objects are routed, so that you understand when they're available to get collected.
Okay.
Like a static object, for example, anything static is immediately rooted
Okay.
because it's always potentially referenceable by your application. You could always add a reference to it anywhere in your code. So that basically that means that object is always in memory, and then everything that it references then is also always potentially reachable by your code. So it's one of those things that if you're aware of how objects get rooted and familiar with the patterns like the disposable pattern and how to use finalizers,
Okay.
then you really won't have to think about it.
Okay.
You'll have a better understanding about how they work, so you'll know how to use the system properly.
Okay, tell me a little about the using construct, because I think this ties into the finalizer pattern and the disposable, I'm saying that my terminology is all wrong. But
That's
I
all right.
think it does some of that for me, right?
Yes. Probably the simplest way to think of it is you can think of the using statement as shorthand for newing up an object
Okay.
and then calling dispose at the end.
Okay, this is the using parentheses, new object
Right.
with the curly brackets, not the using in the top where I'm
Correct.
referencing
Yeah,
namespaces,
not
just to
using
clarify,
namespaces,
okay,
right.
for these guys. Alright, so go ahead, I'm sorry.
No, and that's basically it. You think of it as a shorthand for instantiating your object and then disposing and dereferencing at the end.
Okay, so that's another good thing for me, because I'm a lazy programmer, and that also frees me up. If I'm putting this stuff inside of a using block,
Mhm.
then I don't really need to implement these things like calling and dispose.
Yeah, you don't have to manually call
Implementing a
dispose.
dispose of itself, which requires, I think, implementing that iDisposable interface as well.
Well, you can just call dispose on the object.
Oh, I see, okay.
But another thing the using statement gives you is if an exception is thrown
Mhm.
from in that block, it will still call the dispose for you.
Oh, I see, so no matter where it exits.
So even if it exits because of an exception.
Okay, and then you told me something I didn't know, which was that for each also does that sometimes.
That's something that I recently learned also. In your for each, if you're instantiating an object, the collection in your for each statement, that the framework, and I don't know when this was introduced, but when that for each block exits, it will call dispose for you also, if that collection implements disposable.
Okay, that is interesting. That's good, I use for each, so I'm free there too.
All right.
Anything else?
No, I mean there's a lot of good information out there. Some of the blogs on MSDN are a really good source of information. The primary architect for the garbage collector blogs.
What's his name?
Maoni. He has a lot of good articles about some of the internals of the garbage collector.
Okay.
It's one of those topics where research it, understand it, and then don't have to think about it.
I like that part of it. Now, do you have a blog?
I do have a blog.
Where's that?
PatrickDelancy.com. And you get it too from my Twitter profile has a link to it, at Patrick Delancy.
Patrick Delancy? Thanks a lot.
Thank you. Technology is always better with friends.